So this is actually going to be pretty quick podcast because it's really talking about something we've looked at multiple times. So we're looking specifically at an acid-base reaction. Now this is different than what we did in the first podcast when we had those double arrows and we talked about what was acting as an acid and what was acting as a base in a conjugate acid-base situation. That will have those double arrows. This one, if you look, it's a single arrow. So this is a reaction, and it's looking at the reaction between an acid, which has a low pH, and a base, which has a higher pH. These are called neutralization reactions. So look at, you always produce water and a salt. Well, remember the acid? We know it's an acid because it has H with something. That's what makes it an acid. And we know that the base has, again, some cation, and it is always with an OH. So double replacement, the positive always goes with the negative. So we're going to get HOH, always get HOH, which is another way we can write that, water. And you get a cation with an anion. This is an ionic compound, and it's called a salt. So a salt, typically when we say salt, you think of table salt, NaCl. That is one type of a salt formed from sodium hydroxide, and hydrochloric acid makes sodium chloride. There are a whole category of salts, and those salts are, the definition is an ionic compound formed from an acid-base reaction. Now, some salts can be acidic, some salts can be basic, some salts can be neutral, but you know what? You don't have to worry about that right now. Let's just worry about how to write that. But just a side note, knowing what you produce, that you always get a salt and water, that's a good test question. So look at this sample. Here's an acetic acid. I know it's an acid because there's my H. Here's a base. So I know I'm always going to get H plus OH. Here's your water. It doesn't matter which order. And then what's left? Sodium was a +1. Acetate was a -1. So that's where we get the compound sodium acetate. Remember, you always write the cation first. So it's always going to be whatever this cation from the base. So this comes from the base. And the anion comes from the acid, is where that salt is going to be made. So it doesn't matter if there's a subscript. That's why we just have to balance it. This has 2 hydroxides because calcium's a +1. Treat each thing separate. So +1 hydrogen, OH, we know we get water. Water is always a liquid. And we're going to get a calcium, but remember here calcium's a +2 and chloride is a -1. So that's where the calcium chloride +2 -1. So it's still double replacement. You still have to make the correct compound, the right formula for the salt. And then we go back and make sure everything is balanced. So you're going to end up having a 2 here, and then we'll put a 2, so that gives me 4 hydrogens. Here's 2 hydrogens, here's my other 2. Here's your 2 oxygens, 2 oxygens, 2 chlorines, 2 calciums. That is a neutralization reaction. So then we have lithium hydroxide, here's my base, sulfuric acid. Again, I don't care that there's 2 hydrogens, just make the right compounds over on the other side. So water, I always kind of start with water because you know that that's always going to be one of them. These are all going to be aqueous. We really don't have to worry about the states. It's not like our precipitation reactions. So we know you're going to get water. And what compound then? It's going to be from a +1 lithium with a -2 sulfate. You can use your periodic table to know sulfate's a -2. The way I also know is because it took 2 hydrogens to cancel out the sulfate. That's how I know the charge of this sulfate is a -2. So +1, -2, swap, drop. That's where we make the right formula for lithium sulfate, and then you go back and double and balance all your equations. Okay, now we just have to write the formulas. So we have a +2 magnesium, -1 hydroxide. Remember, nitric acid There's no hydro, that means we have an O. Find what nitrate is. Nitrate has a -1. I'll write this down here. So we know it came from the nitrate. Magnesium hydroxide. So we have an acid plus a base. So we know we're always going to get water. And in this case, my salt is going to be magnesium nitrate. So magnesium is a +2, nitrate is at -1. Remember, you have your periodic table, you have your resources, and then you make sure the equation's balanced. Okay, chloric acid came from the chlorate ion. You ate something icky, it has a -1. That's how we knew it has one hydrogen. Potassium is in group 1. Hydroxide is always a -1. So KOH, so everything in this is a +1, -1. So you always get water and potassium chlorate. +1, -1, it's balanced. Okay, last one. So kind of hit pause and see how you did. Hydrobromic has a hydro. That's how come this time there's no O. Only if there's a hydro, there's no O. And again, the +2 magnesium and a -1 hydroxide. If you want to write the salt first, because you have the charges in your head, +2, -1, and water, again, the order you write the compounds, it doesn't matter. But then don't forget to go back and make sure that you have a balanced equation. Okay, you write in neutralization reactions, just acid plus base, you always get a salt, which is just an ionic compound, and water. So if you look, the next page is just practicing that. Most of you can probably do that in less than 10 minutes. Have a good day.